Hello, my name is Hal. My project partner is Kyle, and we are presenting our project for SENG475 AES-CLI. For the background, AES is widely used symmetric key encryption algorithm. It's standardized in 2001. It is actually the standard encryption for all of your web traffic right now, including viewing of this video or uploading of this video as well. It supports 3 different key lengths, which is 128 bits, 192 bits, or 256 bit. And the class of algorithm is called substitution, permutation, and network SPN. Basically, running through the cipher with 1 bit difference would result in very, very different plaintext. And the block cipher is itself can be used with different modes of operation for byte stream as well. So effectively, different modes of operation would turn AES key generation into a stream cipher of 32 bytes at a time. 16 bytes at a time. Our project is a command line interface, and it can encrypt and decrypt data using 3 common modes of operation, which is Galois counter mode, GCM, cipher block chaining, CBC, and electronic codebooks, ECB. No one should ever use electronic codebook ever, because it's very insecure and automatically AES-CLI also automatically selects algorithm versus version based on the key length. And regardless of how large the file is, it's streaming the file. We're not dumping the entire file into memory or anything like that. For the command line interface, as outlined in the project proposal, the idea that we had is that you can either do a -I, which you can specify an input file, and then a -O, which you can specify an output file. Unfortunately, we cannot get input and output to work, and also, unfortunately, we couldn't get the GCM authenticated tag to work as well, which I can go into that later as well. For our demo, it's really quickly, I have already compiled the binary just for the sake of speedy demonstration, but we are going to remove all the test file if exists. We're gonna build the binary and released, and we are going to basically encrypt a plain text text file, which is contained hello world, and then the output would be like test ciphertext underscore mode, and then -M over here specified the mode that we're using, and then that applies for both for all 3 GCM, CBC, and ECB as well. So going to the demos, as you can see, if I do a cat test, we have our 32 byte random bytes for the key over here. If I run the demo script that I have made earlier, you see that data integration is violated, and I can go into that later. But before that, we can look into some of the different files over here. So if I do a cat plaintext.txt, you get hello world. If I do cat test ciphertext CBC, which is like the first mode of operation that we've implemented, which is not CBC, sorry, ECB, which is electronic codebooks. You see that we have a bunch of gibberish data. If I do, if I open that in NeoVim in binary mode, you see that it's a random bytes over here and no longer hello world anymore. Plain text. Yeah, so even in binary, it's still hello world for plain text as well. Same goes for CBC as well, and same also goes for GCM, random text. The only issue with the error message that you've seen earlier where data integrity is violated is one of the bugs that we could not solve in time, unfortunately. For AES GCM counter mode, there is an authenticated tag, and the idea is that as you encrypt the data, you compute the authenticated tag, and then you append that to the binary at the end. And then when you decrypt the data, you decrypt it all the way through, but along the way you still calculate the authenticated tag, and then you compare it with the last 16 bytes, which is like the original authenticated tag. If the tag matched up, then the data hasn't been tampered. If they don't, then you get this. Again, unfortunately, we never got the time to fix that issue, and we also never got the time to deal with standard input and standard output as well. Thanks.